finished photoelectric effect and Planck's quantum theory. So these two topics are completed. So these two topics belongs to experiments leading to Bohr's quantum number. Experiments leading to the formation of Bohr's quantum model. Experiments to the formation of Bohr's quantum model. So now here, for finishing these two, next we are going to follow this. We are going to explain about the spectra. See, if you want to know, so go for screenshot of this one. Again, I will explain to you photoelectric effect. See, simple, you can say easily in a light suitable frequency, in a light of suitable frequency, he is incident on metal plate. So electrons are emitted. These emitted electrons are called as photoelectrons. So incident frequency is more than the emitted frequency. So the minimum frequency is required here. The minimum frequency is required by the photoelectrons to emit is called as threshold frequency. Very important. Photoelectrons are emitted. The minimum frequency called threshold frequency. So with this threshold frequency, the photoelectrons are emitted, and with this incident frequency, this light is incident on the black body. So here, incident frequency is always more than the threshold frequency. Why? Because this is emitted, this is incident, this is emitted, this is injected. It means it is falling on the injected on the incident on this one. So here we can take more frequency, but emitted frequency is less compared to this one. So only here we go to frequency of incident radiation is greater than frequency of threshold frequency. So here when we allow to incident radiation on this, emitted electrons are emitted. These electrons are called photoelectrons, and this effect is known as a photoelectric effect. This total process is called as photoelectric effect. Photoelectrons are emitted with the minimum threshold frequency. Finally, here we can write energy. Kinetic energy. We can write the energy of emitted photoelectrons. Energy of photoelectrons is the energy of photoelectrons. Energy of emitted photoelectrons. Kinetic energy is equal to h mu minus h mu naught, because h mu is energy. We are taking from Planck's quantum theory. So kinetic energy is h mu minus h mu naught. So mu, if you take this mu naught to this side, the plus will come. So h mu is equal to k plus w naught. W naught is a work done in a threshold work done. So this is the expression which is used to calculate the problems for the term. So here we can write k is equal to h mu is equal to half mv square plus 1. In the presence of k, you can write as half mv square. So take this one, and if one knows, go for screenshot. So next one, we are going to discuss the spectra. Next topic of this spectrography is spectra. So look at here. So here in this we are going to discuss what is a discontinuous spectra. What is discontinuous spectra? What is continuous spectra? Continuous spectra. Line spectra, band spectra, emission spectra, and sixth one Absorption spectra. Absorption spectra. We are going to discuss all these points here. Discontinuous spectra. So how discontinuous spectrum is formed? From where discontinuous spectrum is formed? So next, continuous spectra. Continuous spectra. From where continuous spectrum is observed? In where line spectrum and band spectrum are observed? And what is emission spectrum and what is absorption spectra? We discuss now. Emission and absorption spectra. So very very important. So now here, so if you look at here, first we can explain about. So firstly we can explain about what is continuous and what is discontinuous spectra. Look at here, continuous spectra. If you take first one as continuous spectra, first one as continuous spectra. Look at here, when solid is a solid or liquid, solid or liquid, when a solid or liquid, when a solid or liquid. So if you incident a light on this, if you incident a light on this, so if you incident a light on this, or if these both are undertaken to electric discharge, both are undertaken to electric discharge, and then electric discharge. Electric discharge. So that means electricity is passed through it. Electricity is passed through it. So electricity is passed through it. Electricity is passed through it. Electric discharge. One can write as electric discharge. So in here, when the liquid or solid are undertaken to electric discharge, so here continuous spectrum is formed. Due to this, continuous spectrum is formed. Continuous spectrum is formed. So why this continuous spectrum is formed? The reason is, see, look at here, in the solids and liquids, intermolecular attractions are more. Intermolecular attractions are more when compared to gases. When compared to gases, and in solids, close packing of particles are there. Close packing. This is a solid here. Inside it, the close packing is there. Close packing. Like this here also. Close packing is there. Inside the particles are closely packed. So only you can write like this. And here also, when you compare this, when you compare to solids, liquids are not much of that closely packing is there. But closely packing is there. Not much of the, when compared to solids, not much of that is there. So here also when compared is both, when compared to gases, both are closely packed, and intermolecular forces are more. Intermolecular forces are more. So when it is undertaken to, when it is subject to electric discharge, when these are subject to the electric discharge, solids and liquid, continuous spectrum is formed. Because here you do more intermolecular forces, So you can write here the point as solids and liquids, subjected to electric discharge. Continuous spectrum is formed. Continuous spectrum is formed. Why? Because intermolecular forces are formed and particles are closely packed. And like that, second one, discontinuous spectrum. Discontinuous spectrum. See here, this is a gas. This is a gas here. So look at here. In the gas, intermolecular forces are lesser. intermolecular force are lesser, and particles are not much as closely packed like solids and liquids. So particle to particle distance are more here. So when it is subject to electric discharge, 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 when it is subject to electric discharge. So here the particles, the intermolecular force are less, the particles are not much of closely packed and distance are more. So only here the discontinuous spectrum is formed. Discontinuous spectrum is formed. Discontinuous spectra is formed. Discontinuous spectrum is formed. So here we can write as when a gas is subjected to electric discharge. Electric discharge. Electric discharge. Discontinuous spectrum is formed. Discontinuous spectrum is formed. Because why discontinuous spectrum is formed? Because the particles are not closely packed. Closely packed. Intermolecular distance are more. So you just write this one parallel to this one and parallel to this one. If you want notes, take a screenshot. Next, line spectrum and band spectrum. Line spectrum and band spectrum. So look at here, line spectra. So if you take a atom, when a light is falls on it, light is incident on it. Okay, so automatically here the line spectra are formed. Line spectra. That means a line spectrum has a characteristics of line. Atoms have characteristics of line spectra. Atoms have characteristics of line spectra. So this is also called as atomic spectra. This line spectrum also called as atomic spectra. Atomic spectra. This is also called as atomic spectra. Like that, when a light falls on a molecule means two or more atoms combined to form a molecule. So here the band spectrum is formed. Why? Because molecule is having two or more atoms, that means group of atoms means large band is formed. So it is called a band spectrum. So here we can write as a line spectrum. Line spectrum has characteristics of atoms. So it is called as atomic spectrum. Band spectrum has characteristics of band spectrum has characteristics of molecules molecules types of molecules band spectrum is characteristics of molecules because see molecules are combination of group of two or more atoms coming from a molecule. So large band is formed. Molecule is a combination of atoms. So large band is formed. So it is called as a band spectra. It's called as band spectra. So that is about line spectrum and the band spectra. Next, so when you go to emission spectra and absorption spectra, so directly this is very important. So here we are directly writing the difference between emission spectra and band spectra. The emission spectra absorption spectra. Look at here, emission spectra and absorption spectra. How emission spectrum is formed and how absorption spectrum is formed. See, look at here, emission spectrum is formed by the emission of radiation. See, when radiations are emitted, emission spectrum is formed. See, absorption of radiation, absorption spectrum is formed. That means it is formed by emission of radiation. It is formed by absorption of radiations. So second one, so emission spectrum and absorption spectrum. It is formed by emission of radiations and it is formed by absorption of radiations. So second one, emission spectrum is formed by this excitation of electrons. So that means see, look at here, this is a level cell. Emission. So if the electron is here, like that, here also levels are there. Right here, this energy levels are like this. Electrons here. So this excitation, that means it will emit some energy. It will fall to lower level. That is called this excitation. So here, when an electron is here, it absorbs some energy and goes to higher level. This is excitation. This is called excitation. So here there is emitting energy falls to lower level. There are absorbing energy and goes to higher level. So here we can write the point as emission spectrum. Emission spectrum is formed by this excitation of electrons. What about here? Here discontinuous, this excitation, there excitation. So next see here. So after see here it is releasing energy and falling to first level. Here it is absorbing energy. That means here when the energy is releases and the electron is falling from higher level to lower level, here we can say as bright lines are found behind the dark background. So here we can say as bright lines. Bright lines are found behind the dark background. Behind dark background. So that means here bright lines. This is a dark background. The spectrum is like this. So this is a dark background here. Dark background here, bright lines like this. Bright lines are found like this. You can indicate like this. Bright lines. That means here we have some there. Some space is there. Here also space is there. Here also space is there. Bright lines are found in the dark background. But here, look at the third one. So here energy is gaining and going to higher level, from lower level to higher level. So dark lines are found. Dark lines are found. Behind the, see, look at here. Behind the dark background only, behind the dark background. That means, look at here. This is the dark lines. This type of spectrum is found in dark lines. This is called as absorption spectrum. Dark lines here. The spectrum is appears like this. Just look at here. Here bright lines, there dark lines. Behind the dark, both the dark background. So this is dark background and that is also dark background. So bright lines behind the dark background. Dark lines behind the dark background. So this is about the main important difference of emission spectrum and absorption spectra. So if you look at here, emission spectrum and absorption spectra, it is found by emission of radiation. From higher level to lower level, it emits any radiations. Electrons emits any radiations. Electrons lose energy and forming and emits radiations. Due to that, by emitting radiations, emission spectrum is formed. It is found by absorption of radiations. It is absorb any light, it goes to higher level, so absorption spectrum is found. Like this here, emission spectrum is found by de-excitation of electrons. De-excitation means falling from higher level to lower level. So next, absorption spectrum is found by excitation of electrons. For excitation means gaining energy and jumping from lower level to higher level. And like that here, bright lines are found behind the dark background. This is the example for this one. Bright lines. What about here? Dark lines. This is this one. This is for this one. This one. So here bright lines are found behind the dark background, and dark lines are found behind the dark background. So both are dark background, but here bright lines and dark lines are different. So this is about emission spectrum and absorption spectrum. So next, so up to now we discussed about photoelectric Planck's quantum theory, photoelectric effect, and spectra. Spectrum and line spectrum, absorption spectrum, and what is discontinuous spectrum, what is continuous spectrum, and what is the difference between emission spectrum and absorption spectrum we discussed now. So tomorrow we discuss the Bohr's quantum theory. That is about. If you want to know, take a screenshot from this.